Hello and welcome back to 8.2. We're going to wrap up 8.2 today by finding inverse trig functions. Hopefully you're familiar with your trig functions now. Now we're going to go backwards. What if we need to find an angle? So it just says a plane takes off and climbs at a 12-degree angle. Is that angle sufficient enough to fly over an 11,088-foot mountain that is 12.5 miles away from the runway? Or does the plane need to increase the angle of its descent? So first of all, let's pretend like we don't know the angle. Let's just find out where the angle needs to be, right, in order to clear the mountain, right? So if I have my angle here, and I have my opposite side and my adjacent side, that's going to be a tangent function. So we're going to use our tangent of some angle. We're not sure what it is going to be yet, right? And that's going to equal my opposite side. And we know that this opposite side over here is that 11,088 foot height here of the mountain. So opposite is 11,088 feet divided by, and my 12.5 miles, I'm going to need to convert this to feet. So I'm just going to put 12.5 times my 5,280 feet to get that into feet. Okay. So let's take this tangent of theta equals, and if I take my, let's get my calculator here. If I take that 11088 and divide it by, and I got to put this in parentheses because I'm going to multiply 12.5 times that 5280. That's going to give me 0.168. So that's going to equal 0.168. Okay. Well, now I need to find what this angle is, right? So I just want to know what this angle is right here. So what we're going to do is we divide by tangent. We divide by tangent. If you remember from Algebra 1, hopefully, when you have a variable or something in the denominator and you want to bring it to the top, it becomes a -1 exponent. -1 exponent. It's not a very good one. Let's go backwards on that in just a minute so I can get a better -1. There you go. So it's tangent of -1 of 0.168. Okay, so if you remember, if there's like 1 over x and you put it to the top, that's the same thing as x to the -1st power. That's kind of what we're doing here, okay, is we're taking that tangent up to the top and we're giving it a negative exponent. Okay, and that's called an inverse tangent, all right? So we take our inverse tangent, and I'll show you where you find that on your calculator. So right above it, here's my tangent button. Right above my tangent button is the inverse tangent button, right here. So I'm going to take my second function button, boom, and say I want that inverse tangent. And I'm going to go ahead and put that 0.168 in there. And a lot of you guys might have this answer, A and S. That means I can put second function and just put my answer, and I'll just put the previous answer in there and then put enter. And that's going to be about 9.3. So my angle is going to be approximately, and it just disappeared on me. Where'd it go? About 9.5 degrees, right? So 9.5 degrees. So that's what it needs to be to clear that 11,088 height. We're taking off at 12 degrees. So 12 degrees is ample, and they're going to clear the mountain and not, have a disaster on our hands. Okay. So that is an inverse function. That's how it works. So this is what all of our inverse trig functions are. So inverse trig ratio can be used to find the angle of a right triangle when given the two sides. So we use our trig functions to find missing sides. We use the inverse functions to find missing angles. So we have our two sides. So all we just really need to do is say our angle equals the inverse sine instead of the sine. So it's really the same thing, same setup. Instead of just using the sine, cosine, and tangent, we use inverse sine, inverse cosine, inverse tangent to find the angle. Okay? So if a plane has, and doing these problems, you want to draw pictures. Pictures are worth 1,000 words. Okay? So if a plane climbs at 5 degrees, so if we're taking off, we have this triangle, we're taking off like this, and this is 5 degrees. Okay, there's my plane taking off at 5 degrees. And I'm going to draw a little bit of a plane right here because I like drawing planes. All right. Here's my little plane taking off at 5 degrees. Okay. Flies 20 miles through the air. So we're going 20 miles up here through the air. Boom. Okay. And as it climbs, what is the altitude of the plane? So we want to know how high is the plane over here. Boom. To the nearest foot. Okay. And so we know the hypotenuse here. We know our opposite side of our angle. So that is my sine function. And so we're going to use our sine function. And we don't have a missing angle, right? We have a missing side. So we're going to use sine, not inverse sine. Okay. So sine of 5 degrees equals my opposite over 20 miles. Okay, so then I can actually just multiply by 20 on both sides here. Oops, 20, like that. And so when I plug this in here, I can just actually take this calculator now, and I can clear this up, just put 20 times my sine of 5 degrees. Okay, just put that whole thing in there, just like that. Now, some of your calculators might not do that. You might have to be careful of order of operations. So you have about 1.74, okay, about 1.7 or so. So x is going to be approximately equal to 1.7 miles high. Okay, so after it's gone 20 miles through the air, it's gone about 1.7 miles high in the air. Okay? Okay, so what are the measures of angle A and B? So first of all, remember these are complementary because this is 90 degrees. These two, A and B, must be 90 degrees. So if I find one angle, I can find the other angle easily. So A right here is not going to be, well, I guess we could use tangent to find A, or we could use sine to find B, or whatever. So it just depends on which one you want to find. So let's just go ahead and find angle B. Okay. So if I use angle B, then I'm going to use my opposite over my hypotenuse. So I'm going to say, what is my sine of angle B is going to be equal to 1 over 4. Okay. So my sine of B is equal to 0.25. Okay. So now my angle B is going to be equal to my inverse sine of 0.25. Okay. So now I'm going to get out my trusty little calculator here, and I'm going to say, what is my inverse sine? So second function here, inverse sine, and I put my 0.25 and close my parentheses there and enter. So it's about 14.5. Okay. So my angle B is about 14.5 degrees. Okay. So B is 14.5 degrees. We know that A and B must equal to 90 degrees, right? So if I take angle A plus 14.5 has got to be equal to 90 degrees. So if I just subtract 14.5 from each of those, oops, my A is right here. Here we go. All right, so if I just take my 14.5, 90 minus my 14.5, which you should end up with, of course, by 85, that's 75.5. So 75.5 for my angle A. So there's my angle A, there's my angle B. Okay? All righty. What is a measure of angle P? So again, we just kind of want to make sure which angle we're talking about and what are the sides we're given. We're given an opposite side and an adjacent side. So that's going to be our tangent ratio. Okay, so my tangent of angle P is going to be equal to my opposite over my adjacent. So 2 over 3. Okay, so 2/3 is kind of funky to write in decimals. So I'm just going to actually leave it as 2/3. So I'm going to say angle P is equal to my inverse tangent of 2/3. By the way, trigonometry is probably one of the most useful maths you'll ever use, ever. Okay, so second degree or second function tangent, inverse tangent. I'm just going to put 2 divided by 3. Whoops, I think I went too many of these. There we go. So 2 divided by 3, and it's about 33 we'll call it 33.7, round to the nearest 10. So P is about 30. Now I can't remember what it was. 33.7. Yeah, 33.7. 33.7 degrees. And that is my angle. Okay. So we have one more. Why don't you guys try this one and then come back and see how you do. So now we're trying to find the measure of Q. Okay. So to give me a hint, this one is 33.7, right? So this is 33.7. What is Q? Well, all I have to do here is take 90 minus 33.7, right? So what's 90 minus 32.7? 90 minus my 33.7. And what do I have? 56.3. So Q here is 56.3. All right. So here's some just random practice on just basic. I'm not going to go through each of these, but just how to set up my trig ratios, right? And just knowing that I need to find out what x is. And so how do I use the information I have to set up a problem? So I have my angle here. I have my hypotenuse and I have an opposite side. So that's going to be my sine ratio. So knowing which ratios to use is really important. If you get the set up right, then it's money from there. So I'm going to use my sine of 46 degrees equals my opposite side, 24 over x. Okay. On this next one, I have lots of variables here. So I'm just going to pick one. I'm going to pick x first of all. Okay. I have my angle 45 here. So x is opposite. And I have my hypotenuse. So, okay. So I'll probably start again with sine of 45 equals my opposite x over 16. Right. Once I find that side, I could either use cosine or I could use tangent, any of those. Okay. Over here, this time I'm missing my angle, right? So I have my angle and I have my opposite side over my hypotenuse again. So this would end up being my x degrees is going to end up being my inverse sine. And then it's going to be my opposite 23 over 24. Okay. So setting those up are half the battle. Just making sure which parts of the triangle do I have, and so which ratio is that going to be. Okay. So here is all the summary of 8.2 so far. My parts of my right triangle, all my sine, cosine, and tangent ratios. And then you all have a Google Classroom, or excuse me, an Excel and Google Classroom. And then I will hopefully see you guys next week. Have a wonderful weekend, and I'll talk to you soon. Bye-bye.